Hi girls, today we're going to look at the class tasks. So for the first week, we're just sketching parabolas using transformations. Now, I would like to start with CAS, but my CAS is not working on my computer at the moment. So we're going to skip and actually do finding the turning point of a quadratic. So for this one here, just wait for it to load. We have quadratics that can be in all different types of forms. So we can have expanded form, factorized form, and turning point form. So I'll just give you an example of the three different forms. Well, there's probably more than three, but we'll just look at the three. So we can have a equation in expanded form. So we could have y equals x squared plus 2x plus 1. You can have factorized form, and these aren't the same equations, or you can have turning point form. So let's just think of just random numbers. Okay, put 5 there. So we have what we call expanded form, factorized form, and turning point form. Now the three different forms help you draw your quadratic graph. So the quadratic graph, just quickly, is a U shape. Now the turning point form I like the best because it tells us, as it says, the turning point. The turning point is where it goes from decreasing to increasing. So it's your turning point. The factorized form is also nice because it tells us where our x-intercepts are. So we'll cover that another time. The expanded form isn't as helpful, but we can use that for the quadratic formula, which is what we're going to cover in a few weeks' time. So with the turning point form, you can see here is the equation in turning point form. Okay, so we have y equals a x minus h squared plus k. Now the good thing about this is it tells us what the turning point is. It's hk. So if you've got the value of h here and the value of k here. Now your axis of symmetry is x equals h. So what that actually means, and I might do this in different colours just to try to make it look a bit better. So we have our axes. Okay, so we have oops, come on. I think I pressed the button. X, and we have a y. So when we graph it, and I'm just going to graph a random one here. So there's our parabola. This point here is our turning point, so it's called h. Okay. So let's say, it looks like it's about, 3x negative 2y, so you might have negative 3. Whoops, sorry, I ran the wrong way. 3 negative 2. Okay, so it's just the set of coordinates here. Now your axis of symmetry, if you think of the word symmetry, it means the same on both sides. So we're basically cutting the parabola in half. And that goes through this point here, h, which in this case we call 3. So your axis of symmetry is x equals h, or in this case, because we gave it the value of 3, it's x equals 3. So that's what those two things mean. The turning point is where it goes from decreasing to increasing, so basically where your graph turns, and your axis of symmetry is where it splits it in half. Okay, so let's clear all that. Now, you can only read those points when it is in turning point form. So if you remember back to when we did linear equations, when you had y equals mx plus c, that allowed us to see the gradient and allowed us also to see the y-intercept. But if you had something as like 2x plus 3y equals 4, it doesn't automatically mean that that is your gradient and that is your y-intercept. It has to be in this form. So the turning point and axis of symmetry can only be read when it's in this form. Okay, so let's clear that and move on. Okay, so you should have in your workbooks this information. Take note of this minus sign here because that does confuse students. Okay, so what we're going to do, I can't do anything in CAS, but it's just basically reading your equations. So this one here, we have y equals x plus 3 squared plus 1. So if you can just take note here, we have a plus 3. Oops, might just clear that for a sec. See how it's got the minus, I can leave this on the same page, minus h, and this is a plus 3. So it's not, h is not 3. If you think about it, just replace any plus signs with a minus, and that'll prevent you from getting confused. So I hope you're not sitting there thinking, oh, Miss McMullen, you've already confused me. Okay, the reason we do that is because students often think the h is a positive 3 when in fact it's a negative 3 because we have to have a minus there. Okay, and because there's no minus there, we can put a minus in there. So the best way to make sure you don't get confused about it is if you see a plus when it's in turning point form, just replace it with 2 negative signs. So you can see it's minus negative 3. So in this case, we have h equals negative 3 and k is 1. So your turning point for this one is negative 3, 1. And your axis of symmetry is, remember, x equals h, so it's x equals negative 3. Now, is that all we had to do? Now, if you can roughly sketch it, just to get an idea, so let's just draw our axes. So we've got x, y. Let's change the color. Okay, so let's find negative 3. So x equals negative 3 is, just say here, and y equals 1 is here. So your point, negative 3, 1 is there. Now, sometimes you can have negative parabolas and sometimes you can have positive parabolas. So this one here is a positive parabola, and I'll explain that, how I know that in a second. Okay, so there's our positive parabola. And let's draw our axes of symmetry in as well. So when you do this, it's probably a good idea to also sketch it, just so you understand what you're actually doing, because sometimes you do maths and it's just a load of numbers, you don't actually know the application of it. So this is actually linking the graph with the equation, or the parabola with the quadratic. Okay, so the parabola is the graph, the quadratic is the equation. Okay, let's do another one. Let's see if we can find a negative 1. Okay, so G is a negative 1. So have a look at G. Why do you think I knew straight away that it was a negative? If you can see, let me just get my pen. You can see here we have a negative sign. So that indicates to me that we have a negative parabola, which goes like that. It's upside down. Okay, so a positive parabola is a U, and a negative parabola is an upside down U. Okay, so let's clear that and have a look at the turning point. So I'm just going to scroll up so we actually know which one we're doing. Okay, so for G, I'm just going to rewrite it because this is basically what you should be doing in your workbooks. Now, the first thing you should be asking yourself, is there a plus sign there? No, it's a negative. Fabulous. So remember, we don't circle that negative because the negative is already there. So H is just the 3 and the K is also 3. So your turning point is 3, 3. And your axis of symmetry is x equals 3. Now if I was to graph that, and obviously you would have much straighter lines than me. Let's change the color. Okay, so your turning point is at 3, 3. There it is. Now this graph will also have x-intercepts and y-intercepts. The other one only had y-intercept. This one has x-intercepts. But for the time being, I don't want you to be too concerned about that, because otherwise I'm just going to overwhelm you with lots and lots of information. So it's 3, 3 is this point here. It's upside down because of the negative sign. And I'm going to just draw in, excuse me, the axis of symmetry, which is x equals 3. All right, what I'd like you to do now is just pause. So have a go. Let's choose, maybe let's do B. We'll do one positive and H. Actually, no, we'll do, sorry, let's do B. Oh, actually, we'll do 3, H and I. Okay, so have a go at doing those 3 on your own. Press pause and you can come back and I'll do the solution for you. All right, so let's start with B. Okay, so we're going to rewrite the equation. So we're going to do B first. Y equals x plus 2 squared minus 4. Now remember, if you have a plus sign in there, just write it 2 negatives. Okay, so that'll just prevent you from getting mixed up with your H. So remember, we've got to have the negative outside the circle. So there's that one, and there's our K. And if you think, why have I circled that? Because in your turning point form, which is above, it's a plus there. Okay, so your turning point is -2, -4, and your axis of symmetry, oops, don't need that, is x equals -2. So if we're going to quickly sketch that, okay, let's change the color. So we've got -2, -4. So there's that point there. It's a positive parabola, so it's going to be a U shape. Again, we should be looking at where it crosses the x-axis, but I'm not going to do that now. Too much information for you if I do that as well. Okay, so -2, -4. And then your axis of symmetry right down the middle at x equals -2. All right, let's have a go at H. So we have y equals -x minus 2 squared plus 6. So I know straight away it's going to be a negative parabola, but let's highlight our H and K values. So we've got to leave that negative in. So there's H, there's K, so your turning point is at 2, 6, and your axis of symmetry is at x equals 2. So when we're graphing that, let's choose another color. So we've got 2, 6, so there's 2, there's 6, let's draw a dot there, and always label your graph. So if you've got a turning point, you should be labeling it. So we have 2, 6. There it's a, remember it was a negative parabola, that's why it's upside down. X equals 2 is our axis of symmetry. All right, moving on to I now. So we have y equals -x plus 1 squared plus 4. Okay, I know it's a negative parabola. I'm going to rewrite that. Okay, so I've got a plus there. Change it to 2 negatives. Let's highlight or circle here and this here. So that's H. Okay, so your turning point is at -1, 4. Your axis of symmetry is at x equals -1. Let's graph it. And see how quick I'm doing it. So not that I expect you to do it as quickly as me, but the turning point form is fantastic because it allows you to straight away see what your turning point is. Okay, so there's our graph. What do we got? -1, 4. And there's your axis of symmetry down the middle. Now with your, I was just thinking, your x-intercept and your y-intercept, there is a way of doing that, and it isn't difficult, but I'm just going to leave it like that for now. Okay, so please, I know that, I hope you're not sitting there thinking, oh, they're not accurate graphs. The thing that we just want to focus on now is the turning point and the axis of symmetry, and we'll do the intercepts later.